We are in the page replacement concept. So first of all, before going to discuss about page replacement, I need to give a review of page fault. What is a page fault? Page fault means the required page is not available in the main memory. That means whenever you refer a page, that page is not available in the main memory. How can you know that the page is not available in the main memory? That means you need to check in the page table. So whenever there is bit I indicates in the page table, in the page entry, then automatically it indicates that it is an invalid page. That means the page is not available in the main memory frame. Whenever the page is not available in the main memory frame, automatically there will be a trap to the operating system. All right, I will show you the diagram once again. This is the diagram, right? So you need to understand this diagram thoroughly, then only you can able to understand why we go for the page replacement algorithms. What is the need of going to the page replacement algorithm, right? So here I require load M. This page I require. So whenever I require a page, I need to check whether the page is available in the main memory or not. So follow the cursor. First step, there is a refer to the page. So what it indicates in the page table entry, there is no frame number in the page table entry, so that the page is not available in the main memory frame. Whenever the page is not available in the main memory frame, it is indicated by the bit invalid I. Okay, that means it is an invalid page, and whenever there is an invalid page reference, then automatically trap to the operating system. Then what the operating system will do? Operating system will look for the page in the backing store. Okay, the page is available in the backing store. Okay, if the page is available in the backing store, what operating system has to do? The operating system has to load the page into the main memory frame. In order to load, this particular point is very critical, so concentrate. Whenever the page is in the secondary memory, we need to bring that particular page to the main memory. Whenever you want to bring that page to the main memory, there need to be a free frame. If the free frame is available in the main memory, then only the operating system is able to load that particular page into the main memory. If the free frame is not available, then the page replacement algorithm concept came into a picture. In this particular diagram, there is a free frame. Free frame is available. So what the operating system did? The operating system brought the page from secondary memory to main memory and keeps it in the free frame. Whenever it is in the main memory free frame, automatically we need to update the page table. Step 5 is reset the page table. What is the need of resetting the page table here? So we need to modify it to V. V means valid. That means now the page is available in the main memory. That point you need to send back to the program in order to execute the instruction, in order to restart the execution, load M. Okay, that is the thing. So if there is a free frame, okay, in the main memory, if there is no free frame, what you have to do? If there is no free frame, what you have to do? For example, now you want to load M, right? So you refer that particular thing in the page table. Refer to the page table, whether that particular page is available or not in the page table. This is the page table, right? So whenever you refer to that particular page, so it indicates that that page is not available in the main memory. So it will be indicated by I. So whenever it is invalid, automatically there is a trap signal to the operating system. The required page is not available in the main memory. Then automatically operating system check that particular page in the secondary memory. Check that page in the secondary memory, that is called as backing store. Now the M is available here. Okay. So whenever the required information is available, required page is available in the secondary memory, we need to take it and keep it in the main memory, right? So now this is the main memory. The main memory is divided into frames. Now there are no free frames available in the main memory. So already main memory is occupied with some other pages. There is no free frame. There is no free frame. So whenever there is a no free frame, then what operating system has to do? So we need to swap out. We need to swap out one page and we need to swap in a required page. For example, here in this particular case, we have 4 pages in the main memory. In those 4, we need to select one page as victim. One page as victim. So in order to select this victim page, we need to run the page replacement algorithms. Are you got my point? We need to run the page replacement algorithms. So which page we need to take out from the main memory? That thing will be decided by the page replacement algorithms. Okay, so we need to replace one page with the required page. So for example, I am selecting A as a victim page. So what I will do? So I will take out this particular A from the main memory and I will keep the M into the main memory, so that I need to reset the page table. What I need to reset? Now the load M is available in the which frame? 0, 1, 2, 3. The load M is available in the 0th frame and now I need to replace it with a valid bit. Again A is available earlier A is available, right? All the 4 things A, that means page A, B, C, D, all are available in 0th page, 1 page, 2nd page, 3rd page. Now this 0 is occupied by M, right? So that is the reason why we need to, earlier it was valid. All these pages are valid earlier. Why? Because all these 4 pages are available in the main memory. So valid. Only M is not there. That is the reason why it is invalid. So now what we are doing, there is no free frame. That is the reason why by using a page replacement algorithm, we choose A, first page. Page A is a victim page. Victim page for example. So we need to replace A with M. So we need to keep the M into the main memory and we need to update the page table. We need to reset the page table. What we need to change? We need to change I to V and then we need to change this one. Now A is not available in the main memory and V has to be changed to I. Why? Because now A is not available in the main memory, right? And you need to restart. So whenever there is no free frame, whenever there is no free frame and there is a page fault means what is page fault? What is page fault? Required page is not available. Required page is not available in main memory. So we need to bring this particular page from secondary memory to main memory. But in the main memory, there are no free frames. Whenever there are no free frames, we need to replace one page with a required page. Which page we need to select as a victim page? That will be done by the page replacement algorithms. Are you got my point? So there are so many page replacement algorithms. So there are so many page replacement algorithms. That is the concept. Now we are going to solve some of the examples. The first one is the first page replacement algorithm is FIFO. What is FIFO? FIFO means first in, first out. First in, first out. So for example, here we need to take a reference string. Based upon the reference string, we need to solve the problem. So whenever this particular page replacement algorithms appear in your question paper, definitely there is a reference string, right? What is the reference string? For example, 7 0 1 2 7 0 1 2 0 3 0 4 2 3 0 3 2 1 2 0 1701. So this is the reference string. Okay, for example, this is the reference string. So what you have to do in order to solve this reference string, first you need to check what is first in first out, and next how many number of main memory frames are available. So we need to consider whenever the page replacement algorithm question appear in your examination paper, you need to check which algorithm, and next what is the reference string, and the third point is how many number of frames, how many number of frames per process. In this particular example, we have given 3 frames per a process, three frames per process. So 3 frames means how many number of boxes we have to draw? 3 boxes we need to draw. So this is the main memory free frame box, right? How many frames are available? Three frames. Initially we require page number 7. Page number 7 is not available in the main memory, so we need to keep page 7 into the main memory. After that, again page 0 is not available in the main memory, so we need to bring page 0 into the main memory. After that, what we require, this is called as reference string. Reference string, that means these number of pages, in this order we are going to refer the pages while we are executing the process. Whenever you are executing this particular process, these pages are required. What is a page? What is a page? I repeat, a process is divided into pages. And next, process is divided into pages, and then main memory is divided into frames, right? So these are the pages. So in order to run the process, we need to keep these pages into the main memory frames. Okay, so now these are the pages. I think you understand the concept, right? 7 and then 0, after that 1 page, first page is also not available in the main memory. That means page 1 is not available, so I will keep page 1 also here. And then whenever there is a requirement of a second page, now there is no free frame. If you observe here, no free frame, right? So whenever there is no free frame, till this particular point we have a free frames, right? So that we can keep the 7 without any problem into the main memory frame. 0 also kept in the main memory without any problem. 1 is also kept in the main memory without any problem. Why? Because up to this point we have a free frames. Then what about 2, second page? We require a second page. Now with the which page we need to replace? So we need to replace with a page which came into the main memory first. What it indicates? First in, first out. That means the frame which was came into the main memory frame first will be removed from the main memory first. That is called as first in, first out. The page which enter into the main memory frame first will be removed from the main memory frame first. So 701. In that, how many number of times each page appears? 7 is appeared 3 times. Why? Because it came long back. Now, next, after that 0 came. After that, first page came into the main memory. So we need to replace 7 with 2. Okay, and then the next page is 0. 0 means 0 is already available in the main memory frame, so we no need to replace anything. After that, what we require? We need third page, page number 3. Page number 3 is not available in the main memory, so automatically page fault. So all these are the page faults, right? Page fault. Page fault means required page not in main memory frame. That is called as page fault. So whenever there is a page fault, we need to take the page from secondary memory and keep it into the main memory, right? Like that here 3 is not available in the main memory frame. So what you have to do, you need to bring this particular page from secondary memory to main memory frame. But the main memory, there is no free frame. There is no free frame. So we need to run the page replacement algorithm. What is the page replacement algorithm? First in, first out.
First out.
0, 1. In this, which one? 2 is just came into the main memory. And next before that 1 came into the main memory, 0 came into the main memory long back. That means 0 when compared to 2, 0, 1. So 0 is came into the main memory first. So I need to replace it with the 3. So 0 is replaced with 3, right? And again, now there is a page fault again. I require 0th page, but the page is not available in the main memory frames. So what I have to do? Again,
1 replace with 0.
1 when compared to 2, 3. So 1 is came into the main memory first. So that is the reason why I replace 1 with 0. And then 4. 4 is also not available in the main memory. So main memory frame. So I need to replace it with the 1 frame.
2 replace with 4.
So 2 is replaced. Why? Because when compared to 3 and 0, 0 just came into the main memory here, and then 3 is came into the main memory here, and 2 is long back. First came into the main memory. So I need to replace it with 3. సో హూ ఎవర్ హ్యావ్ సమ్ డౌట్, మీకు ఇంకొక ఇదంతా టఫ్గా ఉంది అనుకుంటే ఫస్ట్ కమ్ ఫస్ట్ సర్వ్లో ఆ ఫస్ట్ ఇన్ ఫస్ట్ అవుట్లో సో మీరు ఏం చేయొచ్చు, ఏ నెంబర్ అయితే మ్యాక్సిమం నెంబర్ ఆఫ్ టైమ్స్ కనిపిస్తుందో బ్లైండ్గా మీరు దాంతో రీప్లేస్ చేయొచ్చు. నెక్స్ట్ ఎగ్జాంపుల్ చూడండి, అప్పుడు మీకు అర్థమవుతుంది. మేబీ ఫస్ట్ ఇన్ ఫస్ట్ అవుట్ ఇదంతా మీకు టఫ్గా అనిపిస్తే దెర్ ఈస్ ఎ బ్యాక్ డోర్ క్లూ. సో ఫర్ ఎగ్జాంపుల్ 432, ఈ 432లో ఏది మీకు మ్యాక్సిమం నెంబర్ ఆఫ్ టైమ్స్ కనిపిస్తుంది చెప్పండి.
3
చేసుకున్నప్పుడు 4 ఓన్లీ 1 టైం, బ్యాక్ వెళ్ళినప్పుడు 3 టైమ్స్, 0 2 టైమ్స్. సో 3 మ్యాక్సిమం టైమ్స్ కనిపించింది అంటే మీనింగ్ ఏంటి, 3 మెయిన్ మెమరీ
చేంజ్ చేయాలి.
సో దాంతో రీప్లేస్ చేయాలి. అట్ విల్ బి కన్సిడర్డ్ యాజ్ ఎ విక్టిమ్ పేజ్. ఓకే,
0.
And then 3 is also not there in the main memory, again page fault. So whenever there is a page fault, so we need to run the page replacement algorithm if there is no free frame. Obviously there is no free frame. So 420, so 0 it came into the main memory first, so I need to replace it with
3.
0 is replaced with 3, and then 0 is again not available in the main memory. So 4 came into the main memory first when compared to 2 and 3. So 0, 3. 2, 3 is already there in the main memory. So again we need to replace it with 1. Right? So 0, 2, 3, 1 is not available. So 0, 2, 3. So in those 0, 2, 3, so we need to
neglect 2
with 2. Why? Because 2 came into the main memory first.
0, 1
and then
3 neglect
not available in the main memory frame. So 3 came into the main memory first. So that is the reason why 0. Again 0, 1 are there in the main memory, so no page fault. Again 7. 7 means 0. When compared to 0, 1, 2, 0 came into the main memory first. So 7, 1, and
1, 2.
After that 0.
7, 0, 2.
7, 0,
0, 2.
2. And then again 1.
7, 0, 1.
7, 0, 1. So now calculate the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the number of page faults are 15. If it is a 3 frames per process. Okay, so what we have to do now is we need to solve the problem with the 4 free frames. I want to do it here only. So it is also comes under a first in first out. That is the reason why I want to solve the problem. here itself. Right? Now in the second example, what we are going to do, instead of 3 frames, I would like to assign four frames per a process. 4 frame means how many boxes we need to draw? 4 boxes we need to draw.
4 boxes.
1, 2, 3, 4. So initially 7 is not the same reference string here also. Here the number of process frames are 3. If it is 4 frames, okay, 3 frames are more now, right? So 7, there is no 7,
0.
so page fault. 0 is also not there, page fault, but there is no need to run the page replacement algorithms. Why? Because there is a free frame. Here also we don't run the page
701.
replacement algorithm. Why? Because free frame is available. Here also we no need to run the page replacement algorithm. Why? Because there is a free frame.
201.
So after that 0. So 0 is already available in the main memory frame. So no need to run the page replacement algorithm. Okay. So if there is an ambiguity, I will write the same reference string again for you. Right? So 0 is already available, so no page fault. 3 is not available. So the 3 is not available means page fault, and then we need to run the page replacement algorithm. Why? Because 3 is not there, so page fault. Free frame is also not there. Which frame we need to take out? So for
0.
that we need to run the FIFO algorithm. So in those 7 came into the main memory
7.
first. So I need to replace it with the 7. And then 0 is not, 0 is available in the main memory,
Available.
so we no need to run the page replacement algorithm. Now 4 is not available in the main memory.
Main memory.
Which frame I need to
0.
0, I need to replace it with the 0, remaining as it is. Okay, and then 2 is also available in the main memory, 3 is also available in the main memory, and then 0 is not available in the main memory. So
1 is replaced with 0.
which frame I need to replace?
1.
With the 1 I need to replace. And then 3 is already there in the main memory. And next 2 is also there in the main memory. And next 1. 1 is not there in the main memory. So with which frame I need to replace?
2.
With the 2 I
2.
need to replace. 0, 4 and then 3. So 2 is not there in the main memory. Which frame I need to replace?
3.
3. So 2, 4, 0, 1. So 0, 1 is already there in the main memory. After that, seven, with which I need to
4.
replace it. 2, what?
4, ma'am. 7.
4, 7, right? And then 0, 1. So 0, 1 already there in the main memory. So like that fashion, we need to run the FIFO. Okay? And next, there is a problem called as Bilard's anomaly. So what is Bilard's anomaly? So very, very, very important question for you. Okay. So this is the problem in the FIFO. This is the problem in the FIFO. So what the problem in the FIFO is, if you increase the frame number, if you assign more frames per process, then page faults will be more. So actually frames, if we assign minimum number of frames for a process, the page faults need to be more. But in the case of FIFO, it will be done in the reverse order. So whenever you increase the frames per process, automatically page faults also increases. Actually page faults has to be reduced, but in the case of FIFO, whenever you increase the number of frames, automatically the page faults will be increased instead of decreasing the page fault number. In the case of FIFO, it is in the increasing order. So that is called as Bilode's anomaly. Okay, that is about FIFO. And the next one is the optimal page replacement algorithm. Optimal page replacement algorithm. So what is optimal page replacement algorithm? Right, in the case of optimal page replacement algorithm, again you need to given one reference string. What is the reference string? For example, 7 0 1 2 0 3 0 4 2 3 0 3 2 1 2 0 1 7 0 1. Right? So this is the reference string. So in this also we will do one example. This is the reference string given in the textbook, and the next reference string has to be given by you. Okay? Tell me. So in the case of optimal page replacement algorithm, so what we will do? We need to be select a victim page. Excuse me. What is a victim page here? The page will not be used for longest period. The page which is not used for the longest period. What is FIFO? The page which entered into the main memory frame first will be leave from the take out from the main memory first. That is about FIFO. Then what is optimal page replacement algorithm? The page will not be used for longest period, will be selected as a victim page. Okay, here we are taking 3 frames. 3 frames. So there is no page in the main memory. So page fault, again page fault, but there is a free frame. Again page fault, but there is a free frame. Again page fault, but there is no free frame. So what we have to do? So we need to run the page replacement algorithm. What is the page replacement algorithm? Optimal page replacement algorithm. Optimal page replacement algorithm means we need to check in this direction. Remember this particular line forever. You need to check future reference. You need to check the future reference. Whenever the 2 is required, so which page we need to select as a victim page? So 0 we require immediately. 1 we required here, but 7 we required here. So in the near future, we require 0 and 1 when compared to 7. So I need to replace it with the 7. Are you got my point?
7. Yes, madam.
Right, and then 0 is already there in the main memory. Sorry, so 0 is already there in the main memory. So no page fault. Right, 3 is not available in the main memory. 3 is not available in the main memory. So which frame we need to select as a victim? Which page we need to select
0.
as a victim? So 0 we require immediately.
0.
0. We go to the future reference. 0 we require immediately, and then 1 we require here. 3 we require here. In the main memory you have 2 0 1. 0 2 1. So 0 2 require immediately, but 1 we require after so much of time. Okay, so that is the reason why I need to replace it with the 3. Why? Because 0 as well as 2, I need those pages immediately. That is the reason why I will choose 1. And then 0 is already there in the main memory, no page fault, and then 4 is not there in the main memory. So what we need to do? We need to select one page as a victim page. 2 0 3. 2 I require immediately. After that I require
0,
3.
ma'am.
After that 0. So I need to consider 0 as a victim page. 2, 3 already there in the main memory, no page fault. So now 0. So 0 and there is no free frame. So which page?
4, ma'am.
3, 2 immediately I require, 4 I require no longer. In the reference
Yes.
there is no 4. So I need to replace with 4.
4.
Right? 2, 3 is already there in the main memory and then no page fault. 1. 1 means 2 I require,
3, ma'am.
and 3 I don't require. So I need to
Yes.
replace with 3. 2, 0, 1 already in the main memory. And then 7. 0, 1 I already there in the reference string. So 0,
2.
1 already there. Okay. So you now tell me 1 to 0 to 5. Any pages? Any one of you give one reference string, will solve this next problem. Any one of you give the reference string. Sometimes you might not be given a reference in your examination paper. On the time, whenever there is a need to explain about optimal page replacement algorithm, you need to write your own reference string. Right? Tell me. You need to repeat the pages. Tell me any
2,
sequence. 2,
1,
1,
4,
4,
0,
0,
5,
5,
2,
2,
3,
3,
1,
1,
0,
0,
4,
4,
3,
3,
2,
2,
0,
0,
1,
1,
3,
3,
4,
4,
5.
5. Okay. So if it is optimal page replacement algorithm, the victim page will be the page which will be not be used for the longest period. That means you need to check the future reference. You need to have a knowledge about the future reference, what we require, which pages we require in the future. Okay. 2 is not there in the main memory frame and it is and the free frame is available. So no need to run the algorithm. First 3 for first 3 page faults, we no need to run the page replacement algorithm. So whenever there is 0, 0 is not there in the main memory, page fault, and then we need to run the algorithm also. Why? Because there is no free frame. 2, 1, 4. So 2 I require here, 1 I require here, and 4 I require long after some more time. Even after 2 and 1, 4 came into the picture. So what I need to do? So I need to replace 0 with the 4 and then 5. So 5 is also not there in the main memory. So what I need to do? 2 I required here, 1 I required here, 0 I required here. So 2, 1, 0. Which one will be the last? 0 is the last one. So I need to replace 5 with the 0. And then 2 is already there in the main memory. And then 3. 3 is not there in the main memory. So what I need to do? So 1 I require immediately. 2 I require immediately. After 1, at the last I require 5.
5.
I need to replace it with a 5. 2, 1. So 1 is already there in the main memory, no page fault. 0 is not there in the main memory. If the 0 is not there in the main memory, page fault and there is no free frame. So we need to run the page replacement algorithm. So after 0, so which one I need to? So
1, ma'am.
2, 3, 2 I require immediately, 1 long back. So with the 1 I need to
4, 0, 2, 3.
right? And then 4 again page fault. 2, 3 I remove immediately. So that is the reason why I replace it with 0. 2, 3 already there in the main memory. So no page fault.
4,
So we need to choose.
page fault.
So here it might be now the situation. So now
2, madam.
2, why 2?
There is no longer 2, no, madam. Next.
So 2
4, 3.
and then 1. 1 means
0.
3 is not there. So
0.
I would like to change the reference string.
Near 0, madam. Reference
No,
string.
no, no. I want to change the reference string. I want to make some. Right? Now, here if we observe 2, 4, 3, and 2, 3 already there, and next to 0. 0 means there is a 2, 3 already 2, 4, 3. So 3, 4, 3 is not there. That is the reason why it is. What I will do is I will change it to 0. Now tell me. Now tell me. 2,
2,
2,
ma'am.
2,
Changes
3 already
0.
there. 0. So
Change it to, madam.
2, why 2?
There is no longer 2, no, madam. Next.
So actually 3 is there. So we no need to replace it with 3. For sure 3 will be there. Then indoor 2 and 4 will be the victim. 3 is not there, 4 is also not there. Then in that case, what you will do? That is my question. Are you got my point? So if you want to keep a 0, we need to take out either 2, 4 or 3. So when we check in this direction, 3 is there in the reference tree. So we should not remove 3. So we need to take out either 2, 4. So 2 is not there afterwards and 4 is also not there afterwards in the reference tree. In that case, among between the 2 and 4, which one? That is my 2 is no longer there and 4 is no longer there after 0. After 0, 2 is not there and 4 is not there. In that case, which one you would like to replace with the required base? That means at that time you need to check for the FIFO. Are you got my point?
Yes, madam.
Yes,
So
ma'am.
coming to FIFO, in the 2 and 4, 4 is not there. So we need to for the reference. You need to go according to the right.
మేడం డిస్టర్బెన్స్ వస్తుంది మేడం
I mute the device, not a problem. Tell me. Your end only some of the device.
2, ma'am.
In those 2, 3, so 2 came into the main memory first when compared to 4. Okay, 2 came first when compared to 4. 2 appear multiple number of times when compared to 4. That means 2 came into the main memory first when compared to 4. That is the reason why I replaced it with the 2. Are you got my point?
Yes, ma'am.
In some
Yes,
situation,
madam.
it might be the situation. There are 2 frames not there in the frames are not there in the future reference. In that case, you need to go for a FIFO. If it is a dilemma case, then you need to go for the FIFO. Okay, and then 0, 4, 3, and then 1. Which one I need to replace? 1 is not there in the frame. So page fault occur. The page fault occur what I
4,
have?
madam.
565. Third time I am doing it, right? Still you are unmuting your device on your own. 0, 4, 3. So I require 1. So 1 is not available in the main memory frame. So page fault occur. So which page I need to select? So after first frame, 3 is 0 there and 0 is there. That means we should not replace it with 0 and 3. Why? Because in the future we require third page as well as 0th page. Fourth page is not required. So I replace it with 4. Okay. At last 5. Now tell me. 5 is not there in the main memory. So 0, 1, 3. Which frame you will select? There is no future. No string afterwards, right? At the time, what you
3,
have?
ma'am.
So you need to go for FIFO, right? 3 is came into the main memory first when compared to 0 and 1. So I need to replace it with a 3. That is optimal page replacement algorithm. Right? And the next one is least recently used. And the next algorithm is LRU. LRU means least recently used algorithm. Again, the reference stick 70120 30423 03 212 01701. Right? So in that case, what you have to do? In the optimal page replacement algorithm, you are checking in this particular direction, right? So in the least recently used algorithm, you have to check this direction. Are you got my point? I will do it for you, this problem. 7. 7 means page fault. So free frame is available, so no need to run LRU. 0. Free frame is available, no need to run the LRU. 1. Free frame is available, no need to run the LRU. Now 2. There is no free frame, page fault. Page fault, here also page fault, but there is a free frame, there is a free frame, there is a free frame. So we no need to run the LRU. But here, there is no free frame. So what you have to do? You need to run the page replacement algorithm LRU. So which one I need to select? So this direction, which one is the last one? 7. I need to replace it with a 7. Why? Because it is used recently, most recently. It is used most recently when compared to 7. Are you got my point? And the next
Yes, ma'am.
3. 3 is not there in the main memory. So we need to check in this direction. So 0 I referred just now, and then 2 I referred, and then 1 I referred long back. So I need to replace it with 1. Okay? Not being used for the at most amount of time. Okay? The page which has not been used. Page not been used in the most amount of time. That means here the page is, whenever there is a page fault, you need to check whether the page is used recently or the page is used long back. Okay? So 0. 0 is already there, no page fault. And then coming to 4. So 4th page is not available and the free frame is also not available. 0 I referred just now and 3 I referred
2, ma'am.
prior to 3. 2 here. So I need to replace it with 2. Again page fault. Why? Because 2 is not there in the main memory. 4 I referred just now and prior to 4 I referred 0. Prior to 0 and 4 I referred 3. So I need to replace it with 3. And then 3 is also not there. So 2, 4 I referred just now and 0 long back. So 3, 4, 2. Right? 0. Again page fault. Okay? Page fault 3, 2 I referred
4, ma'am.
So whenever you are trying to fill the page numbers into the free frames, first you need to write the victim page replace whatever the page you are replacing, that page number you need to write so that there will be no error. Okay, there will be no problem. Otherwise, it may be a mistake sometime. Right? Always it is a good habit to write a replaced page first. Now 3 is there. Oh, sorry, no need to run the page replacement algorithm. sorry. And 2 is already there in the main memory. So no need to run the page replacement algorithm. 1 is not there in the main memory. So page fault, there is no free frame. So 2 I referred just now.
0 change.
I referred and 0 long back. So first I need to write the page and then remaining parts. Okay. 2 is already there in the main memory. So no page fault. 0 is not there in the main memory. So page fault. So what I have to do?
3 is replaced with 0.
3. 2, 1, 3 long back. We need to check this direction. 3 is in the last position. So 0, 1, 2. 1 is already there in the main memory. No page fault. If it is a 7, 0, 1 is near and 2 is far away. So
2.
0, 1. 0, 1 is already there in the main. So the number of page faults 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if it is LRU, the number of page faults are 12. Okay. If it is a FIFO, same example, number of page faults are 15. So usually 12 page faults means LRU is better than FIFO,
FIFO.
but worse than optimal page replacement algorithm. Okay. LRU is in between both the things. So what is the problem with optimal page replacement algorithm? So optimal page replacement algorithm, we need to know the future reference. In order to do the job, you need to know the future reference tree. Is it possible to you? Is it possible to you to know the future references, which page we require in the future? We don't know, right? So, but the optimal page replacement algorithm is based upon the future reference. Every time you check in this direction, right? How can we know what are the future pages required, right? That is the problem with optimal page replacement algorithm. Then what is the problem with LRU? What is the problem with LRU? So we need to maintain the past history. Past history means which page referred at which time. We need to know that one. Otherwise, so if you not maintain this information, so we cannot judge the victim page, right? Are you got my point? For example, మనకి డైరెక్షన్ లో ఫర్ ఎగ్జాంపుల్ ఇక్కడ 3 కి పేజ్ రీప్లేస్మెంట్ కావాలి. LRU మన victim page, that page is not available in the main memory. 3 is not available in the main memory. So we need to select one victim page. In order to select the victim page, where we checked in the previous direction and which page was referred earlier. So that means this past information you need to know in the case of LRU. In the case of optimal page replacement algorithm, future references you need to know. Okay. So future references we cannot know prior to the execution, right? While you are executing one page, how can we know what are the future pages we require, right? So that is the problem with optimal page replacement algorithm. So in order to maintain the past history, so we need to maintain two things. In the case of LRU, so what we need to maintain? So we need to maintain the past history. Which page referred at what time? So each and every page entry, remember this point, each and every page entry has one count variable, right? So whenever there is a page fault or whenever there is a page reference, sorry, not page fault, whenever there is a page reference, that means page 0 is referred. So automatically at what time the page was referred? For example, 10 o'clock. For example, 7, 0, 1, 2, 3. And then 2, 1. This is a string, reference string. 7 is not there. So I kept in the 7, maybe at 10 o'clock. After that, 0 is not there. I kept in the 0 in the main, sorry. I kept 0 in the main memory at 10 1. And next first page is also not there in the main memory. Again page fault. So 7 0 1. So 10 2. And then 2 is not there in the main memory. Which one I have select? Which one I have to select among 701? If it is an LRU, which one I need to select?
7, ma'am.
How can you say that it is 7? 7 is
It's already used
memory
past.
and back. 7 is used. These two are recently used. 1 is recently used. At 10 2, we have used it 1. At 10 0, 10 o'clock. At 0 first second, we have used 0. And next to at 10 o'clock, we have used 7. That means 7 is used long back when compared to 0 and 1. 0 and 1 are most recently used when compared to 7. How can we say that? With the help of time. We have said that. We have come to a conclusion. 7 was used long back when compared to 0 and 1. How can we say that? Based upon the time only. So we need to maintain that information. For that, in the case of LRU, each and every page entry, for every page entry, we need to maintain a count. What a count consists of? Count consists of clock. And whenever you refer that particular page, for example, there is a page table, right? In the page table, there are entries for the pages. Like that, whenever you refer a page, you need to maintain the information of a clock. 10 o'clock. And then 10 1. 10 2. Like that, you maintain one entry in the page table called count. Okay. So based upon this information, you can select one victim page. Are you got my point?
Yes, ma'am.
Yes, ma'am.
Right. This is one technique. There is another technique, but can I continue or you need to attend for the next session? Clock is one technique and the second technique is a stack. Okay, let me complete this one otherwise. For example, this is the reference string. So what a stack will do? This is the stack. So there is no one.
Ma'am, in reference string, ఎన్ని numbers అయినా తీసుకోవచ్చా reference string లో?
Whatever may be. So, but
Okay, ma'am.
reference string exam lo me note చేసేటప్పుడు there should be some distance between these two numbers. Otherwise, మీరు ఏ నెంబర్ ఏ ఫ్రేమ్ డ్రా చేస్తున్నారని కన్ఫ్యూజన్ ఉంటుంది అన్నమాట. So,
Okay, ma'am.
better to give some gap in between two numbers in a reference string. Okay. And next, those reference string, we need to repeat the reference strings. 1 here, 2 0 4, again 3 1 here, and then 7 2 like that. Okay. Otherwise, every page will be a page fault if you are not repeating. Minimum number of numbers you need to consider. That means in between 0 to 7 like that, or 0 to 6, or 0 to 5. So that now 7 after which page came into the picture? 1. So stack means stack is a LIFO. What is LIFO?
Last in, first out.
First out. So first ఏదైతే ఎంటర్ అవుతుందో లాస్ట్ లో ఉంటుంది ఆబ్వియస్ గా. సో 7 తర్వాత నెక్స్ట్ 1 came into the main memory. After that 7 1 2. After that 0. I will do one thing. I will change it to 7 and I will change it to 2. Then it will be more tough. Right now 7 1 2 and then 7 1 2. After that 0. Again 7 came into the main memory, right? Again same came, and again you are referring the page. Here you refer one time and again you are referring the same page. Then what you will do? 1 2 0 will be moved to down and 7 will be came into top. Are you got my point?
Yes, ma'am.
Again 2. Whenever 2 came into the picture, so automatically 1
1 0
0, 7 will be shifted here, and then 2 will be moved to top position.
Up.
Again 1. So whenever 1 came into the picture, so automatically 0, 7, 2, 1. So obviously what happened? Most recently used page is on top. Are you got my point?
Yes, ma'am.
So now 7 is referred now. We are referring 7 now means we need to keep the 7 in the top position.
Position.
So 0, 2,
2, 1,
7.
7.
That indicates the page which is in the last position will be the best page for replace. Are you got my point?
Yes, ma'am.
And then observe here. So 0 is the best page, I told you. How can I told that? So 0 is referred to long back. That is the reason why it is in the stack last position. So 7 we recently used. 1 before 7, 1. Before 1, 2. And then before 0. So that is the reason why 0 kept in the last position. Now again 2. Again 2 means
0, 1,
1,
7,
2.
2.
And then 1 means
0,
7,
7,
2,
2,
1.
1.
0 means 7,
7,
2,
2,
1,
1, 0.
Always you need to write from the bottom. Okay. 4 means 4 is not there. So what we have to do? 7, 2, 1.
2, 1, 0, 4.
Likewise, so whenever there is a replacement, whenever there is a reference string, so automatically the last page which is in the stack will be considered as a victim page, and the top on the stack will be considered as most recently used. Okay, so these are the two techniques in the LRU. The second technique is a stack, and the first technique is maintaining a counter. What is for counter? We need to maintain counter for every page entry. So what a counter consists of? Clock time. What a clock time? Whenever we refer a page, we need to keep the clock time. We need to keep the clock time in the counter. So whenever there is a need to run the LRU, you need to check that particular counter. Which page? 7th page. At what time we have referred? First page. At what time we have referred? Second page we have when we have referred. Like for each and every page there is a counter variable. For every page there is a counter. So we need to maintain a counter clock values. So that is one technique, and the second technique is stack. Why? Because in the LRU, we need to check the last past history. Based upon the information, we can select the victim page. That means when the page was last referred, that we need to know in the case of LRU. In the case of optimal, we need to know the future reference. In the case of LRU, we need to have an idea about past history. That means when was the page referred last time. That is the reason it is called as least recently used. That means we need to replace with the page. For example, 0. Least recently used among 7, 1, 2 is 7. 2, 1 are most recently used. Just before 0, we have referred 2. Before 2, we have referred 1. Before 2 and 1, we have referred 7. That means 1 and 2 are considered as recently used. And 7 was used long back. That is the reason why. So whenever we want to replace 0, whenever you want to keep a 0, we need to replace it with 7. Are you got my point? Is it clear for you all?
Yes, ma'am.
Okay. Thank you.